Hey guys, this is Mr. H. Hey, I wanted to do a quick video. I was watching a YouTube video of a tutor that was doing some difficult, challenging ACT problems, and there were two questions that she had that she answered, and I thought she did a good job of answering the question. But one of the things that I thought that she could have done a little better job of is just emphasizing the use of the graphing calculator. In my opinion, especially as the questions get more difficult, students should be trying to use their calculators more, not less. And I wanted to kind of go over how I would do those same questions. Um, and so I'm just going to jump into this. All right, so there were two questions. The first one was the number 54. Now these were taken from the ACT, and basically the questions in the 50s are more difficult. And so this is a number 54. So this is considered a difficult question. But the thing here is it says, which of the following number line graphs represents all of the values in the domain of the function y equals log base 10 of the quadratic x squared minus 4x plus 3. Now, for a lot of students get intimidated by logarithms. But in my opinion, this is a domain question. So the best thing that you can do is graph it. So this is what I would do. I would take my graphing calculator and I would go to the graph. I'm going to make this a little larger so you can see everything that I do. First thing I'm going to do is I'm going to hit the tab button and I'm going to enter this log base 10. And the way I do that is right here. We've got a logarithm right here. So I choose that one. And then it's going to be base 10. I tab over. And now I'm just going to enter the quadratic. So it's going to be x squared minus 4x plus 3. And once I've got that, I press enter. Now, as soon as you see this graph, it becomes pretty obvious what the domain is, right? So you can see from here, it's going off the screen. So it's going to a negative infinity. But as I come this way, you can see there is a domain here, but then I'm going down and then all of a sudden there's a gap here. Now, the best way to do this is to use menu 51, which is trace the graph. So you can see as I go to the right, all of a sudden when I hit 1, it becomes undefined, which means there's no domain there. And there's still no domain until I get over to 3. It's still undefined. And then after that, it jumps back on the graph and there's a domain there. So as soon as I see that, I know the answer for this question is K. It's pretty obvious to me that the answer is K. Now, they said it was a function, right? So that's why I think it's just easier to graph it as a function. Now, here's one more thing that's available to you. Let me show this as well. If you go to the table, let's see, do Control T. It also has the table, which will also confirm that choice K was the right answer. You can look when the input is 1, it's undefined. When the input is 2, it's undefined. When the input is 3, undefined. And then all of a sudden, on 4, we have a domain, we have an output again. Now, if we go back, if you see the same thing on the other side, as soon as we get to the 0, we have a domain again. So basically that's saying we have this little spot from 1 to 3 that's undefined, and then we have a domain. So again, I hope that's clear. To me, when you're doing domain or range, it's much easier to look at a graph and find it. All right, so now let's look at the second question. Now, this question, it's not as obvious, but this is also just a range question because we're trying to find the minimum value, right? So basically, we have a function, even though it has all these constants in it, we have a function and we just want to find the minimum. Now, if we had like a regular graph, you would just graph it and find the lowest point. But because it has all these constants, a lot of students just get confused. But here's what I would do. I would put numbers in for H, K, and Q, and then I would graph it. And then I would find the function, I'd find the minimum, and hopefully there'd be something obvious. So let me show you how I would do that. So I would go here, and I'm going to store numbers for H, K, and Q. So my first number is going to be 1.23. And by the way, I like using irregular numbers because those numbers they normally don't show up on the ACT or SAT. So I'm gonna use that and I'm gonna store that into H. So, so now it's stored. Now I'm gonna store another number into K and it's gonna be different. It's gonna be 4, 5, 6. I'm gonna store that into K. Where are you, K? And then I press enter. And then I'm just gonna do 7, 8, 9. And I'm gonna store that into Q. And then I'm gonna press enter. Now that I've stored those numbers are variables, and I can actually graph them when I graph a function. So now let me get rid of the last question. So I'm gonna do menu 14. I'm gonna delete that. And now I'm ready to enter a new function. So my function is just gonna be the absolute value of a negative x minus h quantity squared. Let me actually put that up. So I'm going to just graph this, the absolute value of a negative x minus h squared plus k minus q. And so let me go back to the actual graph and let me do that. So the absolute value is also over here. So I'm just going to get the absolute value. And then I'm going to put a negative parentheses x minus h. And then parentheses squared plus k. And then I'm going to go outside the absolute value, and then I'm going to do minus q. And then I'm going to graph it. Oh, let me say one quick thing. I forgot to say this. If you look, the h, the k, and the q are bolded, which means they are variables, which means there's numbers stored in those letters. That's why those letters are bolded. That means that those are actual variables. Now, okay, so now when I graph this, you can see, let me pull this up a little bit. There's my graph. Now, it doesn't matter what the graph is, I just need to find the minimum. And it's very simple. I just do menu, analyze the graph, and then I'm gonna do minimum. And so I start the lower bound of my graph and I just pull it all the way over. And you can see that the minimum is a negative 7.89. Now, if we go back to, you can see that's the Q value, right? That's obvious that that's the Q value. Now, I'm going to change it. I'm going to make this 10.21. And I'm going to store that now into Q. And then I'm going to press enter. Now, if I go back to the graph, you can see now my the minimum value has changed because I changed the Q value. So that's my confirmation that the answer for this question, it only depends on the Q. That's what I changed and the minimum changed. So the answer for this one is obviously a negative Q. Now, again, if you can look at this and kind of figure out what needs to happen without graphing it, kudos to you. But I think for most students, for the majority of students, if you can graph this, plug in numbers for those constants, and then graph it, it's easier to see where the minimum is. And it's easier to see the relationship that it's K or Q, okay? Now, I think what Brooke did was great, but I just believe that when it comes to domain and range questions, especially when they get more difficult, you should really look to graph. And if you have a graphing calculator, use it. All right, that's my message. Anytime you can graph, it almost always helps you determine what your answers are. I hope this has been helpful. All right, I'm gonna stop.